Today I'm going to be explaining synthetic division, remainder theorem, and the factor theorem. Synthetic division is another way to evaluate a function without directly substituting x into the equation. For example, if we want to evaluate the function f of x equals 2x cubed minus f of x squared plus 6x minus 12 for f of 4, we would, if we wanted to do this by substituting f of 4 into the equation, we would plug 4 in for x, right? So we would have f of x equals 2 4 cubed minus 5 4 squared plus 6 times 4 minus 12, right? And then you would condense these numbers, and we would have 4 cubed, which equals 64, times 2 is 128, minus 4 squared, which is 16, times 5, that equals 80, plus 6 times 4, which equals 24, minus 12, right? And then if we add these up on a calculator, we would get 60. And that's how you would solve it using just substituting x into the equation when f of x equals 4, or when f is 4. Next, we're going to evaluate the same function, but this time using synthetic division. To use synthetic division, you take the first coefficient of every number in the polynomial. So first you'd take 2 and write it down. Then you'd take negative 5 and write it down. Then you'd take 6, and then lastly negative 12. And then you're going to have multiple rows of numbers to finally get your remainder, which is what the polynomial is evaluated to. You'll find your remainder here. And then you also can't forget what you're dividing the entire equation by. That is 4. So we will write that here. To do synthetic division, you'll first bring down the coefficient 2. Then you'll multiply the number in the bottom row, so in this case 2, by our x value, and write that in the second column, in the second row of the next column. So we would multiply 4 times 2, which equals 8. We would write that here. Then we would add the numbers in row 1 and row 2 of the next column together. So negative 5 plus 8, which equals 3. And then we're going to repeat those steps until we get to this box right here, which is the remainder. So now we would multiply 3 times 4, which equals 12. And then you would add 6 plus 12, which equals 18. And then we would multiply 4 times 18, which equals 72. And then we would add 72 and negative 12, which would equal 60. Again, we have evaluated the equation as 60. And we have found our remainder, which is this, the 60. And then this is where the remainder theorem comes into play. The remainder theorem states if you divide a polynomial f of x by x minus h, it will equal f of h. And it equals f of h, then you evaluate the function to the same extent as if you use substitution or long division. This was shown when we got 60 when substituting, and when we got 60 also using synthetic division. The factor theorem is a special case of the remainder theorem, in which f of h equals 0. This gives us the conclusion that the binomial we are dividing by, x minus h, is a factor of polynomial f of x. So we're going to try to figure out if x minus 1 is a factor of 3x cubed minus x squared minus 10x plus 8. So we're going to do this again by setting up synthetic division. So we're going to bring down 3, negative 1, negative 10, and 8 as our coefficients. And since we are dividing the equation by x minus 1 to check if it's a factor, 1, the reciprocal 1 will be what we are using in synthetic division. And again, we are going to bring the 3 down. Multiply 1 times 3, you got 3. Negative 1 plus 3 is 2. And then 2 times 1 is 2. Negative 10 plus 2 is 8. Or negative 8. I apologize. And negative 8 plus 8 is 0. Our remainder is 0. And remember, our factum theorem states that if f of h equals 0, we come to the conclusion that the binomial we are dividing is a factor of polynomial f of x. So therefore, 3x cubed minus x squared minus 10x plus 8 can be factored into x minus 1. Or x minus 1 is a factor of that equation. This means that we can simplify this equation, right? So if we were to factor, we have x minus 1. We know that's a factor. We just found that out. And then we have the other part of our synthetic division here, which is the other part of the factor. So we would have 3x squared plus 2x minus 8. And that is your factored version of this equation. If you multiply them back together, just to double check that this works, you get 3x cubed, right? X times 3x squared. You multiply x times 2x, which is plus 2x squared. X times negative 8 minus 8x. And then you get negative 1 times 3x squared, negative 3x squared, negative 2x plus 8. And then you combine like terms. So we have 3x cubed, 2x squared, and negative 3x squared. That is minus x squared. Negative 8x and negative 2x. That is minus 10x. And then positive 8 is plus 8. And there you go. You are back at the same equation that we started with. And that is the factor theorem.